Can anyone brief like what we did in last class and what you understood from video segmentation?
So we learned about video segmentation and the applications of it, like in medical imaging and then VR and all.
So which model we saw through the model as well, right? So can you brief little bit about that?
So like there was like evaluation metrics part, like it showed what like model how model like predicts in a video and all. So I remember that it compares the predicted one with the actual stuff. That's what I remember. Like one of the models.
That is well and good. So in the last class we saw how the mass Gaussian like kind of tries to goes through each and every frame, do the segmentation and give you the output as an MP4, right? So what was your output like when you did the code part? Like from the code understanding, like can you explain a little bit if you have gone through the code?
So you mean like to explain the codes? Or
Not explain the code, your understanding of the code, how it happened, how it saved to .mp4, how you got the output. That's it. Okay. The working of the code was simple. The thing is that what we do is like we take each and every frame. What we do is like we do segment and we concat everything, all the frames together and give it as a .mp4. So that is what was happening in the code part which was there. Okay, I'll share one code with you. Just a minute. I'll just share one IP where can be found. Just a minute. Alishka, am I audible?
so your voice was not clear. We didn't hear anything properly. We just heard that you
Okay,
said
I'll
you will share a file. That's till the
just
extent.
share one code with downloading from Colab. It's taking a little bit of time. I'm audible now, right?
Oh, yeah, so.
Okay. So I've shared one code as well of advanced topics related to image and video segmentation. So till now we were using mask RCNN. So mask RCNN was developed by Meta company. So those things we just loaded the AI model from the repository. We just run that code and we try to do the segmentation. So from now onwards, what we'll do is like we'll try to develop the models from the scratch and we'll try to train the model. Then we'll try to do the predictions. So in this today's session, like what we'll do is like we'll go through Deep Lab version 3 model. So this is kind of like fine-tuned CNN model. So where we do the segmentation part using the semantic segmentation. So can anyone tell like what semantic segmentation is? You studied from last two classes, last 2 to 3 classes. Anyone? Semantic segmentation.
So, like, it identifies the categories. Like,
Okay, what we do in semantic segmentation?
so I didn't get you.
Notice, okay. We did semantic segmentation, right? So what we do over there in that? There are 3 types, right? Different types of segmentation. What are those?
So, semantic, and then instance and cannot.
Hmm. So what we do in semantic? What is that? Semantic segmentation.
So identifies the class of the objects.
Okay. So out. Okay. So I'll just show you one image. Right. Step. So if you remember this one, right? So semantic segmentation, like what we're trying to do was that. So we're trying to identify similar objects. So with the same classes and those kind of things. Like for example, if there are trees, we would have marked green, and cats or something like that with the same color. So that is what was happening in semantic segmentation. So just remember, semantic segmentation, similar classes in similar colors. So you're trying to segment those things. Okay. Coming into the deep lab version 3 model is there, right? So what we do is like this model has 3 channel. You can take up to 1080p pixel videos and you can just train that one. So you have the larger resolution images. So it supports this image with 1920 also cross 1080 pixels. So if you see other images where we're trying to do segmentation with mask Gaussian and all those things, right? So there was a limitation for the pixel size of the image which we are trying to use. Even if you give larger resolution also, like the output, like what we used to get, like it was trying to compress the image and decompress the image. So encoding and decoder, if you remember. So that is what we are doing in Mask RCN. So what we do in Deep Lab version 3 is that we'll try to use the ResNet 101 model. So that is a type of CNN model. And then that we use as a backbone in order to identify the classes. Then what we do is like we do use ASPP 5 parallel branches. So these are like convolutional layer itself. So what we do is like we'll have them after the ResNet model. So once the classes are identified, so using this ASPP, we'll try to segment. So these are just 5 layers. So additional 5 layers we're adding after ResNet 101 model. So what we do is like sorry, this ASPP forward pass. What it has is that so we'll take these convolutional strides and those things like we define in 5 different lines. So one is that branch 1x, then branch 2 is r is equals to 6. Like we'll try to define over here what is b1, b2, b3, and b4. So we'll try to concat all these branches. So we'll define the forward pass. So DNN, those are similar to that. We are trying to do the forward pass. So once you start coding, you'll try to understand like what's happening in each layer, and then we'll try to see the output as well. So hope you understood this one, Deep Lab version 3. So you can just upload the code which I shared with you in Google, in your Google Drive, and then we'll try to run the code. So since my internet connection is low, can anyone share your screen? We'll try to run from your system. So I just shared the code. Can anyone share your screen and you can just run the code?
Yes, I'm like saving. So is my screen visible?
Yes, it's good. You can start running the first part of the code. So what we're trying to do is like we are trying to load all the necessary libraries. So and then we are trying to set the device as a CUDA device or whether it's CPU it has to run and those things. So it's just the initial run in the first part. So it's just trying to import all the necessary libraries. So we are using PyTorch and those things. So Torch Vision and other related Python libraries. So NumPy, Matplot, Pillow, and Request and those kind of things.
So it's executed. Can I run the next part?
Yeah, you can run the next part. Can you just give me a minute, just a minute. Okay, so am I audible now?
Yes, sir.
Everyone left. Okay,
So
so
Kenneth is there.
can this is there? Okay. Okay, I'll try to explain like what is happening. So the core idea of this Astras in Deep Lab is that how we take the convolution and how we try to give the deceptive field. Uh, okay, so I'd explained you like we are trying to use 5 layers, right? So in that, what we do is like first we do 3 cross 3 convolution, then 13 cross 13 convolution, then 25 cross 25, and 37 cross 37. Okay, coming into this 3 cross 3. So when the value when we set it to r is equals to 1, right? So receptive field, what we do is like by standard procedure, we do take 3 cross 3 matrix. So, okay, Tanishka, shall I share my screen? That would be better for explaining.
Okay.
My screen is visible, right?
Yes, sir.
Yes, sir. Okay. So what we do is like whenever we pass any image, right? So what we do take 3 cross 3. So 3 cross 3 is nothing but your matrix of 9 pixels. So 3 rows and 3 columns. So then what we do is like each and every column and each and every row, we do try to do the convolution, next 3 and next 3, so on. So when we are trying to do this convolution, right? So what we get is that each and every convolution, like it will try to reduce this size by 1 pixel in each row, and like after the output results. So those kind of things you'll try to get. So what we do is like in this standard convolution, R is equals to 1 receptive field 3 cross 3. So when we try to receive this, just for the definition, I'm just showing. So this one, 3 cross 3, whatever the output we are trying to get the residue of those things. So we'll try to consider the middle value. So this should be considered and taken for the output results for each and everything. So when we are doing for these three, so the middle value would be taken. And then when we are trying to do, the middle value would be taken over here. So it's just like we are trying to do the convolution. And then once again, if we do convolution, so this pixel value we would be getting. So we'd be considering those in order to reduce encoding thing. So for that we try to use encoding part. So then coming into 13 cross 13. So 13 is mm, so 13 cross 13. This would be the 13 cross 13. Sorry. Okay, so 13 is over here. This one would also come. So 13 cross 13 matrix. So when we try to do the convolution, so this one would be passing over to next over here. So what we do is like the middle values we try to take, and this value we'll get. And then we'll try to shift. One more shift we'll do. This is the last shift. Get this value and this value, 3 shifts. So then what we do is like we'll take the convolution from this part. Let's change the color. So then what we do is like we do take this part and this part. So this is this right. We'll get the value for this one. Like what we're trying to do is like we are trying to arrange those segmentation part over there. And then the next part we try, sorry, this was supposed to come from over here. 13 pixel is there, right? So 13 it will come over here. So for the second part it will come this part and this over here. Then we'll try to get these values, these values, these values, and so on. So third part, segmentation over here. So for this green we'll get over here and then so on. So this one and this one. So that is what happens in 3 cross 3. So coming into 25 cross 25, right? So it will try to take the complete pixel size of 25 cross 25 and it will give you one input. So it's more than like it's kind of more than, sorry, less than 25, right? So that is why it will take the single value. So if you can see around 15 pixels are there in rows and 15 in columns. So when we try to use 25 cross 25, it will take the whole thing and it will try to give you one result value. So similarly for 37 cross 37 as well. So since it's 15 cross 15, it will take the middle value like of those things, convolution values of those things. So hope this is understood, this part how we got each and every values. Is this clear? Uh, you have any doubts regarding this one?
Sir, like I understood like what's happening here, but I didn't get like what's going to happen next.
Okay, so what we do is like when we do these kind of things, right? So we'll try to concat every values. So I'll get to know like once you start, like the main idea is that so we have to get the values, like we have to encode, right? So the segmentation is nothing but encoding and decoding. So if you remember in previous classes, like what we did. So mascarin, if you see over here, like it was trying to reduce to 1 cross 100 or something like that, right? So if you convolve and it was reducing the size. So what we do is like we try to encode everything. So this is convolution part. So decoding is nothing but upscaling convolution part. So using the similar idea but using different calculation method. So that is what they're trying to do in Deep Lab version 3.
Yes, I got it.
So we do convolution in order to reduce the pixel size and get the like kind of average value and try to get the what is it, edges and those kind of things would be there as parameters, right, in order to define any classes. So for that we use the convolution. Just run the next part of the code. Is it already late? You have any other things you have to do in today? Is it fine if I take for 5 more minutes?
I can stay, sir.
Okay. Or else if you want, I can take in next class. So I hope you understood these many parts. Mm. So this is the important part. Like what we try to do is like we do try to do four different kinds of convolution. So one is by 3 cross 3 convolution, then by 13 cross 13 convolution, then 25 cross 25, and then 37 cross 37. So what we do is like we'll try to get all these values. We'll try to keep it aside, one side, and then we'll try to do the calculation for those. So I'll try to explain in next class in details for this everything. So only like you understood we are doing the calculation. So why we do and what we get, I'll just explain in next class. Is that fine? It will take some time for this to explain.
Okay.
Okay. So everyone can run that code. It will try to run. So you can see your outputs as well. So like each and every step, you can see like what's happening in each and every stage. And you can check that out, check the code once, then send the screenshot of the output one in the WhatsApp group.
Yes, sir.
Tanishka, you can stop recording. If you have any doubts, you can just ask. I'll just answer those.